Alright, so we're going to be looking at the unit circle in this video, and while you might have done some pre-work around it, I just want to make sure that we can consolidate your understanding of the unit circle and the properties of each quadrant, because this is going to then pave the way for you to be able to solve trigonometric functions. So with the unit circle, we know it has a radius of 1 unit and it can be divided into 4 quadrants. So the first quadrant is anywhere between 0 to 90 degrees. Now that you've looked at radians, I'm going to also say, it's way too thick, I'm going to say that that's also from 0 to pi on 2. Quadrant 2 is anywhere between 90 degrees to 180, so that's pi on 2 to pi. And then quadrant 3 is 180 degrees to 270, which is pi to 3 pi on 2. And then quadrant 4 is 270 to 360 degrees, which is also from 3 pi on 2 to 2 pi. So we know that whichever way we look at it, it's a full revolution. So when the angles are positive, they are measured in an anti-clockwise direction. And when the angles are negative, they're measured in a clockwise direction. For a majority of the work that we're doing in this course, we will be looking mostly at positive angles, but just keep in mind that we can have negative angles as well. Alright, so now looking at applying the trigonometric functions to a unit circle. So there's a couple of things here we need to look at first of all, and I'm just going to start by labeling a couple of things. So if we look at the horizontal axis, so that's our x-axis, it's actually also known as cos. And then our vertical axis, which we know as y, is actually sine. So if we look at this particular right angle triangle, so if I follow along here, this is the same as saying cos of an angle. And the length here is going to be sine of this reference angle here. So if we take a look at this point, and I'm going to label that point P, that's the same as saying that the coordinate is cos of theta, comma, sine of theta. Now, for the purposes of this, I'm just going to write here that I'm going to say cos of theta is equal to A and sine of theta is equal to B. This is just going to make it easier when we start labeling each of the quadrants. So with the first quadrant, so this is quadrant 1, all values are positive here. So when we're talking about our angle here, it's going to be sine of theta is equal to B, cos of theta is equal to A, and tan of theta is actually equal to B over A. The reason being is that tan of an angle is equal to sine of the angle over cos of the angle, hence why it's B over A. So this is the property exclusive to quadrant 1. So now I'm just going to change colors as we move over to quadrant 2. So with quadrant 2, there are a few changes here. First of all, in order to work out what the reference angle is, what we're going to do is actually work our way backwards. So if we're working in radians mode, we would do it from pi minus the angle. So I'll just write here, rad would be pi minus the angle, and then in degrees, we would do it as 180 minus the angle. So if we look at our trigonometric ratios here, we're going to have sine of pi minus the angle is equal to B. So sine of theta. Then we've got cos of the angle, so pi minus theta is equal to negative A. And then tan of pi minus theta is going to be negative B over A. It's not negative B over A, sorry, it should be B over negative A. But we would write it that way anyway. So with this particular point here, we would write this coordinate as negative A, B. Now when you think about where it exists on the Cartesian plane, we know that our x values are negative in the second quadrant and our y values are positive in the second quadrant. So I'm just going to quickly write here that point P has the coordinates A, B. So now moving down to quadrant number 2, quadrant 3, we've got a few more changes here. So again, we're looking at our reference angle. So we're going to do pi plus our angle here, or 180 degrees plus our angle. So here I'm going to write in radians, we're going to do pi plus our angle, and then in degrees we would do 180 degrees plus our angle. So the trigonometric ratio properties would be the following. So sine of pi plus theta would be negative b, cos of pi plus theta would be negative a, and then tan would be pi plus theta, which would give us b over a. So this point down here would have the coordinate pair negative a, negative b. Now if we think about again what we know about this particular quadrant on a Cartesian plane, both x and y values are negative, and this is consistent with what we know, so that sine has a negative value, cos has a negative value, however tan would have a positive value, and that's just because it's sine divided by cos. So moving on now to our final quadrant, so that is the fourth quadrant, I'm going to draw another dotted line down here. Again, I'm going to have my reference angle, and this point here is going to be represented by the coordinate pair a, negative b. Now quadrant 4 will have the following properties. So again, with our radians, this time we're going to do 2 pi minus the angle, or in degrees mode, we would do 360 minus the angle. Now it'll have the following properties here. So sine would be, and this is in radians, 2 pi minus the angle will give us negative b, cos of the angle, so 2 pi minus the angle, will give us positive a, therefore tan will be negative, with it being negative b over a. Now just keep this in mind, because this is obviously going to become a lot more useful when we start to solve trigonometric functions. In this course particularly anyway, we will be switching between degrees and radians, so just keep that in mind as well. So with your radians, remember when we are converting degrees into radians, so for example, if you have 180 degrees and you need to convert that to radians, we would do pi over 180, and that will equal pi. That's from degrees to radians. And if you're going from radians to degrees, so for example, pi on 2, you want to convert to degrees, we would do that times, just thinking, 180 divided by pi, so that would give us 90 degrees. Alright, so if we move into defining circular functions now, the first question asks us to actually evaluate what sine of pi is. Now, if we go back to the unit circle, so I've got another excerpt here, we know that if we label it, so we're obviously working in radians mode here, so I'll do 0 to 2 pi, that would signal the start and the end of my unit circle, or a rotation, Then we've got pi on 2, pi, and 3 pi on 2. If it helps, label your y-axis with sine and label your x-axis with cos. Alright, so if we've asked to evaluate what sine of pi is, if we look at our unit circle, so pi is there, sine in this case would be 0. And that's because cos of pi at that point, or when the angle is pi, cos is equal to 1. And if we take a look at our unit circle, where I've highlighted that, we know that that coordinate would be negative 1, 0, remembering that the x value represents cos and the y value represents sine.